Hey everyone, and welcome to MAC 1105, section 1.1, linear and rational equations. I want to just go through and explain what a linear equation is. An equation indicates that two algebraic expressions are equal. Whenever you see something where you have an equal sign, you call that an equation. Linear equations in one variable is an equation that can be written in the form ax plus b equals c, where a, b, and c are real numbers. And most important, a can't be equal to 0. If a is equal to 0, then you can see that what you would have here would be, you wouldn't have an x, you would just have 1 equals 1. It's important that a is not equal to 0. The linear equation has everything is to the first power. So we don't write to the first power, but we assume if there's no exponent that it is to the first power. That's what makes something a linear equation. And what we're talking about here is a linear equation with only one variable. We can see this is also a linear equation because the y is our variable and it's to the first power. And here, again, the same thing. A is our variable, it's to the first power. This would not be an equation because it doesn't equal anything. We would call this just an expression. We can't solve expressions, they just are. But we can solve equations. Basically, I'll show you the steps. The first thing we want to do is we want to get rid of the parentheses. The first step is eliminate parentheses. Whenever I have something that looks like this, I have to distribute the 5 to the x minus 6 because that's going to help me eliminate my parentheses. The first thing I'll do is I'll distribute. When I distribute, what that means is that this 5 gets multiplied by both terms. We end up with 5x minus 30. 5x because I multiply 5 times x, and then minus 5 times 6 is 30. Now I don't need that parenthesis anymore. Minus 2x equals 3. And then now we have this minus in front of the parentheses. And you could really look at it as there's a minus 1 in front, and we're going to distribute that. A negative 1 times x would be negative x, and negative 1 times positive 1 is negative 1. Now I've distributed, and the next thing I want to do is I want to combine like terms. I can see here on the left-hand side that I have a 5x minus 2x. 5x minus 2x is positive 3x. That takes care of this and this. And then minus 30 equals, and I'm going to again combine like terms on the right-hand side. So I have this 3 minus 1, which gives me 2 minus x. Isolate my variable. Whatever I do to one side, I have to do to the other side. Here, I'm going to get my x's to the left-hand side. I leave the 3x there, but I'm going to add x to both sides. So I get 4x minus 30 is equal to 2. And minus x plus x cancel. That's why I added x, so that I could get rid of that x on the right-hand side. Now I need to get that 30 away from the x, because we want to get x on one side and everything else on the other. So how am I going to do that? I'm going to add 30 to both sides. I get 32. And on the left-hand side, these are going to cancel, and I get 4x. I'm going to always do adding and subtracting first here. Let me see. I'll say we're going to add and subtract first. And the reason is because we don't want to multiply or divide first. Then we'll start making fractions. Now, 4x is the same as 4 times x. I do the opposite operation, which is division. I'm going to divide both sides by 4. And these cancel. And I end up with x equals 32 over 4 is 8. And that is my final answer. I would say add, subtract first, multiply and divide second. Number 2. Now, some of you might think, oh no, fractions. Usually that happens. Don't worry. We're going to do exactly the same thing. We're going to follow our steps. What were our steps? We're going to eliminate the parentheses by distributing. We're going to combine like terms. We're going to isolate the variable using addition and subtraction first and multiplication and division second. First thing I'm going to do is I'm going to distribute. I have 1/3 times 1 is 1/3 minus 1/3 times x is 1/3 x. And you can write that as 1/3 x or x over 3. 1/3 x is the same as x over 3. Whichever way you want to write it is fine. Minus x plus 1 over 2 equals -2. Now notice really what we have here is fractions. Actually, I'm going to rewrite this as x over 3. I think this might help. It's exactly the same. Now, whenever I want to add or subtract fractions, I need a common denominator. I always want to find my LCD. Adding or subtracting fractions. My least common denominator here is going to be 6 because my denominators are 3 and 2. They have no factors in common. I'm just going to multiply them together and I get 6. Number 2, I'm going to multiply both sides by my least common divisor. I'm going to multiply this side by 6, and I'm going to multiply this side by 6. And let's see what happens. I'm going to distribute. I get 6/3 minus 6x over 3 minus 6 times x plus 1 over 2 is equal to, and this I could just say -2 times 6 is -12. Now, why did I do that? Because I can cancel. I can say 6 over 3 is 2. And again, 6 over 3 is 2, so I have 2x. And here, I can cancel this 6 and this 2, and that would give me 3 times x plus 1 is equal to -12. Let's keep going. I have 2 minus 2x, and now I'm distributing that -3 into the terms in the parentheses. So I get -3x minus 3 equals -12. And now I'm going to combine like terms. I have 2 minus 3, which is -1. And then I have -2x minus 3x, which is -5x. and that's going to equal negative 12. I'm going to add 1 to both sides because I'm isolating my x. These cancel. I get negative 5x equals negative 11. And then I'm going to divide both sides by negative 5. The way that signs work for division is exactly the same way they work for multiplication. A negative times a negative is a positive, and a negative divided by a negative is positive. The negative 5 and the negative 5 cancel, and I get x equal, these negatives cancel, and I just end up with x equals 11/5. And now we have decimals. I can do it either with decimals or without decimals. Let's do it first with decimals. Again, I just begin, I'm going to distribute. I get 0.1y minus, and then if I multiply that, I get 0.2 plus 0.03y minus 0.12 is equal to 0.02 times 10 is 0.2. Now, that looks kind of complicated. I look at my decimals. This is tenths, this is tenths, hundredths, hundredths, and tenths. Basically, decimal point and one number after it, or a decimal point and two numbers after it. Since the smallest placeholder that I have is in the hundredths place, which means I have two numbers after the decimal, what I want to do is multiply both sides by 100. If I multiply both sides by 100, then every time I multiply by 10, I move the decimal one place to the right. For example, if I have 0.1 times 100, and what I'm going to do is I have two zeros here, so I'm going to move this two places. So that gives me 10. If you do this on your calculator, this would be 10, because I've moved the decimal point two places to the right. I have two zeros. I'm going to move this one decimal place, two decimal places, and wherever I don't have a number, I would put in a 0. I'm going to multiply both sides by 100. And now, just like I showed you, 0.1 becomes 10y minus, and then I'm going to move this two decimal places to the right, so it gives me 20, plus, if I move this two decimal places to the right, I end up with 3y. And again, if I move that two decimal places to the right, I get 12. And that equals 0.2 times 100 is 20. And now I no longer have decimals. Now I'm going to combine my like terms. I have 10y plus 3y is 13y. And then I have minus 20 minus 12 is minus 32. And that still equals 20. I'm going to add 32 to both sides. These cancel. I get 13y equals 52. Divide both sides by 13. And I get y equals 52/13, which is equal to 4.